Hello, class. Today, what we are going to talk about is performing similarity transformations. Okay. Now, before we talked about rigid transformations, congruence transformations, right? Rigid motions. These are things they transformed the figure, but they didn't actually change the shape. They didn't change the size, and so they were congruent. This was your translations, the reflections, the rotations. Now, last time we looked at dilations in the last video, and we saw that that did not maintain the figure's size. It changed the size. It didn't change the shape, but it did change the size. And what it is a similarity transformation because it is the same shape, but it's a different size. So it's similar. Right? So a similarity transformation, here, technical definition here, is a dilation is a transformation that preserves shape but not size. So a dilation is a non-rigid motion. Now, a similarity transformation is a dilation, a composition of dilations, or a composition of rigid motions and dilations. All right. Two geometric figures are similar figures if and only if there is a similarity transformation that maps one of the figures onto the other. Similar figures will always have the same shape, but not necessarily the same size. Okay, so basically what this is saying is similar figures are figures that have had some kind of dilation involved, and then it can be moved from one to the other. All right, is the way we do this. Okay, so it's going to either use just a bunch of dilations, or it's going to use dilations and then the rigid motions to get it where you need it to go. Okay. Congruence transformations preserve length and angle measures. When the scale factor of the dilation is not equal to 1 or -1, then it is a similarity transformation and it preserves angle measures only. So the angle of your image will be the same as the angles of the pre-image, but the shape, the size will be different, the length of the sides. And just to refresh us, we have right here all of the different rules for all of our transformations. Remember these first three, translation, reflection, and rotation, these are congruence transformations. These are rigid motions. They do not change the size. They do not change the shape. Dilation is a similarity transformation. It will change the size, but it will not change the shape. So all the sides will be proportional. The distance from the center will be proportional. All that's proportional because they're similar. All right, so let's take a look at some of these examples. So on these first three, 1 through 3, we want to graph the polygon with the given vertices and its image after the similarity transformation. So step 1, graph the original. Quadrilateral ABCD, we want to translate this according to the rule x minus 5, y minus 3. So all that's going to do is take all of the x values, move them 5 to the left, and then all the points are going to go down 3. So that's easy enough. So we take point A and go over 1, 2, 3, 4, 5, and down 3. 1, 2, 3. Right there. A. And we do the same thing with the other 3 points, connecting our points with a straight edge. Okay, now, this one's a little bit more difficult. Here we want a dilation centered at 0, 0, where k is 3. Remember, k is the scale factor. But it's still not too bad because the center is 0, 0. So all we have to do is multiply all of our coordinates by 3. Might be easier to have our coordinates written down. Let's write down our coordinates. And I don't know about you. Personally, I find it easier to do dilations from the coordinates, not from the graph. All right. So all I have to do is take all of these points and multiply them by 3. So a prime prime is going to be -2 times 3, which is -6. Then 3 times 3, which is 9. Then we do the same thing with our other points, multiplying the x and y coordinates by our scale factor of 3. Much easier than trying to count up and count over. I mean, we could do that. Let's see, C is 1 unit away from our center, so now it needs to be 3 times that, so that'll be 3 units away. C prime prime. D is 2 units above, so now it's going to be 2 times 3, so 6 units up above the center. So d prime prime. A little bit more difficult here. Okay, we're going 3 over and 2 up, so I need to go 3 over and 2 up, and then 3 over and 2 up, or I can just multiply it out. Negative 9, 6. Negative 9 and up 6 puts it right there. B prime prime. And negative 6, 9. Okay, so 9 is going to be here. And there is A prime prime. And we take our straight edge, because we don't want to freehand this, or your teacher might count off if your lines are all wobbly. There it is. So not too bad. Not too bad. All this is, these are just compositions of figures. You're going to take the first figure one and then the second one. Okay, so here we did translation, then dilation. On number 2, we're going to do dilation and then reflection, not because of any specific rule, just because dilation is listed first. So that's what we're going to do first. Okay, simple like that. So what I would like you to do, pause the video, work out number 2, and then come back. You can do this either graphically or do it algebraically. I personally prefer algebraically. So either way, pause the video, work this out, then come back and see how you did. All right, you're back. Let's see how we did. First thing I'm going to do, I'm going to go ahead and graph my original. Okay, so I'm going to do this algebraically instead of doing it on the graphs, right? That way I'll only end up with my final answer on here. The original and final answer, that's what it wants in the instructions. Graph the polygon and its image after the transformation. So we just want the original and the final answer. So let's see here. Okay, so we're going to dilate with a center of 0. K is 1/4. So all we have to do is take our K, multiply it by our points. So for R prime, 1/4 of 12 is 3. Then 8 times 1/4, 1/4 of 8 is 2. So that is my intermediate step, my middle step. Now I want my reflection. Reflection in the y-axis. What is the rule for reflecting in the y-axis? Hopefully you remember this, but if not, it's y-axis, negative AB. So all we're going to do is change the signs of the x value. That's it. Okay, so let's just change the signs of our x values. That's easy enough to do. R prime prime. So 3 becomes negative 3, and the y value stays the same. So there it is. We've got our 3 points. Let's plot them. And there's my answer. All right. A bit different, right? Because it's facing a different way. It might be a little bit hard to see, but this is still a similar figure. Similarity translation. R prime prime, S prime prime, T prime prime is similar to RST. Okay, because all we did was a dilation, which changed the shape. It would have put it down here, and then we flipped it over the y-axis. So they're still similar figures. Okay, good. Now let's take a look at number 3. Again, I would like you to pause the video, see if you can work this one out on your own, and then come back and check your work. All right, let's see how you did. First, let's plot the original. Always a good way to start. So, first thing it wants us to do is rotate this 90 degrees about the origin. So we're going to take it. Remember, if it does not say which direction, it's always going counterclockwise. So it's going this way. All right. And if I rotate that, it's probably not even going to fit on my picture here. So let's just take a look at our rule here, just so we can remember it. 90 degrees counterclockwise, and we have AB maps to negative BA. So we're going to change position, and B becomes changes signs. So that means X prime, the 5 comes to the front and changes signs. So that's negative 5. The 10 moves to the back. Y prime, 2 moves to the front and changes signs. 4 moves to the back. And Z prime, 5 moves to the front and changes signs, and the negative 2 moves to the back. All right. And so that would put our triangle over here somewhere, probably sticking outside of the grid. Yeah, definitely sticking out of the grid. We want negative 5, so it's going to be out here. So, next thing it wants us to do is to dilate from the center of 1, 1. That is a bit more complicated, isn't it? It doesn't have a center of 0, 0 like these did. Here we have a center of 1, 1. So this is going to take a little bit more work. Let's double check our rule for this, because it's a bit more complicated. So if we're centered on point AB, what we want is the scale factor times x minus a, in parentheses, then plus the a. And then same thing for y. We're going to take y minus the y value of our center, multiply that by the scale factor, and then add that y value back in. So let's take a look at this. All right. So let's do x prime first, x prime prime, I guess, technically. So first we have the scale factor, which is 2/3, times the x value, which is -5, minus, let's see, what was it? The a value from our point of our center of dilation, so -1. And then we're going to add that 1 back in, so +1. All right. Then we're going to do the same thing with the y value. So that will be scale factor of 2/3 times the y value, which is 10, minus the y value of our center, which in this case is the same thing, it's 1. And then we're going to add that 1 back in, so +1. All right, let's see here. So this still shouldn't be too bad to work out. -5 minus 1 is -6. 2/3 of 6, well, 6 times 2 is 12, divided by 3 is 4, plus 1 is 5, -4, and so this will be -5. So x prime prime, the x value is going to be at -5. Let's see here. 10 minus 1 is 9. 2/3 of 9 is 6. 6 plus 1 is 7. All right. All right. Nope, not here. This should be 3. That was -6. 2/3 of -6 would be -4. +1, a negative plus 1 is going to be a positive, a -3. Sorry about that. So that would be -3/7. So x is going to be at -3/7 right here. X prime prime. Okay, now we do the same thing for y prime prime. And there it is. Not bad. Not bad. All right, let's take a look at this next set. Number 4. 4 through 6, it wants us to describe a similarity transformation that maps the pre-image to the image. So what they're doing in this one is saying, okay, here's the image and the pre-image. How do you get there? Before we're saying, okay, here's how you get there. What's it going to look like? Right? This one's saying, here's what it looks like. How did you get there? So this is a little bit more complicated sometimes. Not too bad. Now, what I recommend personally, all of these are going to have to do with dilations, right? So which was an easier dilation? Dilating from the center, dilating from 0, 0, or dilating from some point other than the center, 1, 1? Which one was easier to do? Dilating from the center, from the origin, right? That was much easier. So let's do that, because that's the easiest one to do. Let's do that first. So always start with the dilation. Get your figures the same size, get them congruent, and then from there, then you can do your rigid motions to put it where you need to put it. Okay. So taking a look at this, we're just going to pick one side. It doesn't matter. We'll just use NM. NM is 2 units long. That corresponds with N prime M prime, which is 1 unit long. So to change this to that, our image is half as long as the original. So that means I need a dilation. So I'm going to do this here. Dilation. And we're going to center it at 0, 0. Center is going to be 0, 0. And K is going to equal, let's see here, it was 2. I need it to be 1, so I need to be half as big as it was. so k is 1/2. All right, so now we can either work this out algebraically or we can work it out graphically. It's up to you. I'm just going to do this algebraically because it's easy enough to do. So let's see here. We have m is at, let's see, 1, 2, 3, 4. M is at 4, 0. I want half of that, so m prime is going to be at 2, 0. All right. N is at 4, 5, 6. So n is at 6, 0. Half of that will be n prime at 3, 0. L is at, let's see, 1, 2, 3, 4, 5, 6 right there. So L is at 6, 6. Half of that puts L prime at 3, 3. Okay, so if you want to graph that on there, that's fine. We can do that too. Not where we want it. So now how do we get it where we want it? Well, it's in the same orientation. So all I have to do now is just move it over, right? So I'm just going to pick a point. I see L to get from L to L prime. Here we have down 1 and over 1, 2, 3, 4. So my rule, this is just a slide. So we're going to translate. And the rule for this, we're going to take wherever our x, y is, and we're going to map it. X, let's see, x needs to add, we said 4, right? 1, 2, 3, 4 to the right. So x plus 4, and then y is going to go down 1. So y minus 1. All right. So our solution here is we're going to have the dilation and then the translation. And that gets us where we want. Dilation from the center with a scale factor of 1/2. The dilation centered at 0, 0, sorry. Dilation from the origin, scale factor 1/2, and then a translation, 4 units right and 1 unit down. All right, so not too bad. Always do the dilation first. Now, is there another way we could do this one? Sure, there's almost always another way we could do this one. Looking at this, we could just figure out another way to dilate it. If you remember, the dilation are all centered on with these rays. So we could have these rays going from one point to the other point and then keep going. So we're going from here all the way through that. Same thing with N through N prime, L through L prime. And we end up with, I drew L prime a little bit off. There it is. Right here. We could do this with as a dilation with a center where all these rays intersect, which is right here. That would be 8, -2. And k equals 1/2. And that would do it all in one step. But that's a little bit harder to see, a little bit more complicated to do, especially if your homework is online or something like that and you don't have graph paper handy. So that's a bit harder to see. And sometimes this won't work anyways. For example, on number 5, if you drew lines through this, they are not going to match up. And because we have something other than just a straight dilation here. We obviously have a reflection happening, right? And so doing this isn't going to help. And just do it the first way. Just dilate it from the center, from the origin. Keep saying that wrong. Okay, so let's take a look at number 5. We have, let's see, here's ABC. Here is A prime, B prime, C prime. So we're going from the little one to the big one. First thing we're going to do is the dilation. Get it the right size, okay? Okay, so let's see. Segment AB is 2 units. It needs to be 4 units, right? So what's our scale factor? Remember, scale factor is new over old. So that would be 4 over 2, right? New over old, which is 2. So that's going to be my K. So we're going to dilate from the origin. Always go from the origin. Dilation center is at 0, 0, and k is going to equal 2. So that's step 1. So let's work out where this is. All we got to do is take all these points and double them, right? And we can do this graphically. We can do this whichever way you like. Since a lot of you probably are doing this on homework and things, you're not going to have access to graph paper. I'm going to do it algebraically. And I want to get these over here. And we can tell this just by looking at it right here. We're definitely going to be a reflection, right? Double check our rule, reflection of the y-axis. All we're doing is changing our x values, right? So does that work? Can I just change my x value and see what it needs to be? Yes, I can. Can I change my x value here and get b what it needs to be? Positive 6, 2, that works. And same thing with a, positive 6, that's a 6. So that's all I need to do is just change that x value so that is a reflection of the y-axis. And so this is our rule. This is for our transformation. All right. For those of you who need to see it, I'll go ahead and plot this in here. So some people are very visual. I am one of them. I really do like to see the plots. So, like that. And so there you can see it is a reflection. All right. Okay, last one. I would like for you to work this one out on your own. So pause the video, work this one out on your own, then come back and check your work. How do you get from quadrilateral PQRS to quadrilateral P prime, Q prime, R prime, S prime? Right? And you're back. So let's see how you did. So we're going from the big one to the little one. So the first thing we want to do is to dilate. We need to figure out our scale factor. I'm just going to pick a side. How about we go with segment P prime, Q prime? Right here, so that would be new, which is 1, over the old, which is 3. So there's our scale factor. So the first thing I want to do is to dilate. Center is going to be the origin, 0, 0. K is going to equal right there. That would be 1/3. So now I need to work this out. I'm going to take everything and divide it by 3. So I have P is currently at, what is that, -6, 3. -6, 3. So that puts B prime is going to be at 1/3 of -6 is -2. 1/3 of 3 is 1. All right. Q is currently at -3, 3. -3, 3. So that's going to move it down here to -1, 1, because we're just dividing everything by 3. R over here is at -3, 0, oh, no, 0, -3, 0, -3. So that's 1/3 of 0 is 0, 1/3 of -3 is -1. And S is at -6, -3. -6, -3, so that is going to move it to 1/3 of that will be -2, and 1/3 of that is going to be -1. All right. So there's that. Now, okay, let's just go ahead and plot this so I have some reference. And now we can see, yep, that's going to be a reflection. That's not too bad. So we need to reflect this in the y-axis. So our answer, we're going to do the dilation, and then we're going to do the reflection. All right. All right. So hopefully that's what you got. Remember, when you are finding the rule for a transformation, always do the dilation first, because it's easier if you start with a center at the origin and just dilate it down or up, whatever, and then rotate it or reflect it to get it facing the right way, slide it into place. If you already have the rules, always make sure you do the rules in the order they are given. If it says to dilate first, dilate first. If it says to rotate first, rotate first. Do them whatever order they give it to you in. And finally, don't forget to use your coordinate rules. They will make things much, much easier. For the most part, it is easier to do this algebraically using the coordinate rules than it is to do it graphically. Hopefully that helped you, and I'll catch you in the next video.